Good afternoon. I'm Jackie Burgess Bishop, CEO of the National Kidney Foundation of Illinois, and it is my privilege to welcome you to our 2024 Black History Month webinar on the topic of how African ancestry can affect your kidneys, a discussion on the APOL1 gene. I would like to acknowledge this time and thank our sponsor, UI Health, the Community Relations Department, as they support our mission of NKFI, which is to improve the health and well-being of persons at risk for or affected by kidney disease through prevention, education, and empowerment. Moving forward into our program, I am pleased to introduce our webinar moderator, Monica Fox. Monica Fox is the Senior Director for Outreach and Government Relations for the National Kidney Foundation of Illinois. She's also a kidney transplant recipient with a passion, an absolute passion, if you know Monica, for educating and empowering patients to take control of their kidney health. Monica is the co-host of the Journey Continues podcast, and I want to state she serves on multiple advisory councils. She is a member of several civic organizations, including the South Suburban chapter of the Links Incorporated. And with that, Monica, it's my pleasure to turn our webinar over to you. Thank you.
Thank you, Jackie. First of all, I want to call everyone's attention to the Q&A button at the bottom of the screen. We are leaving time for questions and answers at the end of the program. So as we go along, if a question comes to mind, please put it in the Q&A section and we will work to get all these questions answered at the end of the program. And the chat button is also active. So if people want to put in the chat where you're tuning in from, where you're joining us from, that'll be great. We'd like to see that so we know who's here with us. Now it is my sheer pleasure to introduce my friend, Joanne Howard. After Joanne and I graduated from Hillcrest High School, she went on to pursue her education and became a Chicago public school teacher who worked with the special needs population for 29 years. She served as a vocational coordinator, helping diverse learners obtain the skills that they needed to obtain gainful employment. I know that was truly rewarding work. Joanne serves on the Ann Foundation advocating against gun violence, and she's a proud member of Alpha Kappa Alpha sorority, along with our CEO, Alpha Kappa Alpha Sorority Incorporated, I should say. And after about 10 years, I'll say about 10 years ago, Joanne and I reconnected through social media and our kidney journeys. And she's a dedicated volunteer here with us at NKFI. And we really appreciate her willingness to share her kidney journey with us today. I'll turn it over to Joanne now.
Hello, everyone. My name is Joanne Howard, and I have chronic kidney disease. My story began when I was 28 years old. I started having pains in my side. I went to my doctor, and he did a series of tests. He informed me that I had polycystic kidney disease. And I asked, what does that mean? He eventually told me that down the line, maybe when I'm older, I may or may have to go on dialysis. I had no real concerns at this time because I had normal kidney function. Fast forward 8 years, I married and started my family. And that's when my kidney issues began. Upon pregnancy, my kidneys started to show signs of failing. Toward the end of my pregnancy, my kidneys started to decline. My baby was delivered a month early, by C-section, and I was then put on blood pressure medications. After my baby was delivered, my kidney function went back to normal, and I continued to take blood pressure medications, even though I didn't have blood pressure issues. But I was told that they wanted my blood pressure to stay within a certain range as not to put stress on my kidneys. About 10 years after that, my doctor noticed some changes in my kidney functions, and he recommended me to see a nephrologist. I saw a nephrologist for the first time 13 years after I was diagnosed. And at that time, that's when I gained more information about kidney disease and what it entailed. I started having symptoms immediately after I saw a nephrologist. My kidneys went into rapid descent, and that's when I learned a little bit more about it. I started dialysis within that same year, peritoneal dialysis. I started out 5 hours a day, and eventually it worked up to 8 hours a day while I was still teaching. So I retired early, and then I sought out as much information as I could about kidney disease and all what it entailed. I joined and started volunteering with the National Kidney Foundation of Illinois, and there I found out about the APOL1 gene and its variants and how that may affect kidney disease. How that it may affect one's decision making in terms of their decision to donate or during transplantation. 8 friends of mine came forward to donate to me, but nobody was a match. And at this time, I realized the disparity in the African American community about kidney disease and things like that. And I just did as much research as I could to find out more about it. I was told that my disease was autodominant, so I had my daughter tested. She was tested and told she did not have PKD. At the age of 7, she was hospitalized. She started showing symptoms, and I was told that she did have PKD. So information is vital, and it's vital, especially for the African American community, because it needs to be disseminated throughout. And I just feel, or I felt in my personal journey, the disparity between information within the African American community, because I had good insurance and all these things, but I was totally oblivious to the disease and just everything that happened. So I was listed in 3 states: Illinois, Wisconsin, and Texas. I received my kidney in Texas. I learned through a news report that there was a such thing as a kidney swap. So I inquired at my transplant center, got more information, and since my niece was already tested for me, she had consented to go into the swap program with me. So a couple, they actually matched each other, but they decided to help someone else. So my niece's kidney was a match for his wife, and his kidney was a match for me. And John and Liz are forever a part of my family. I'm grateful to everybody in their sacrifices for me. My daughter now is involved in 2, she's enrolled in 2 research programs for PKD. And these are things that were maybe or maybe not available to me at the time, but I had no idea. So the research is ongoing, and I'm grateful for that. And she now serves as a researcher. She's a recent graduate, and she's a researcher for studies for African American diseases. I just want to say that transplantation is not a cure, it's another form of treatment. So you still have to maintain your health and be in compliance with the medications, diets, and so forth. And the more information you can get the better off you'll be, the more informed you'll be to make correct choices for your health.
Thank you so much, Joanne. You have really enlightened us. Thank you for sharing your story. I know it's helped someone else. The important thing that I heard is that knowledge is power.
Yes.
And so it is important that we that we continue educating people as we go along. And I am so proud of your daughter for working in research, and I look forward to having her as one of our panelists sometime in the future.
Well,
So thank you, Joanne. And now I am honored to introduce Dr. Suneel Udani, who's the Physician Research Director for Nephrology Associates of Northern Illinois and Indiana. He's an internal medicine doctor who specializes in nephrology. He's nationally known for his work and contributions to research and treatment of nephrotic syndrome. He's got many published articles about different kidney diseases like FSGS, for example. Dr. Udani is committed to helping his patients navigate kidney care and to slow or stop the progression of kidney disease. Consequently, he has patients who travel from neighboring states to see him. All that said to say, he's really smart, caring, and kind. And despite his very busy schedule, he finds the time to volunteer with us as the current chair of our professional advisory board. We appreciate Dr. Udani overall, and especially for sharing his expertise on this important topic today. Dr. Udani, I'll turn it over to you.
Thank you so much, Monica. I'm going to share my screen and make sure we can. Okay, let's make sure everyone can see. And everyone can see my slides. Well, thank you again for the kind introduction. I think I was overly generous, to be honest. And thank you, Joanne, for sharing your stories. That's really what makes it all sort of meaningful. And very much appreciated to the APOL1 for first hosting this webinar and an extremely exciting and interesting topic and inviting me to be a part of it. I will certainly say that I am an enthusiast and very much interested in this topic and excited about the progress we've made. I am not the world's expert, and I've benefited from the work and knowledge that many others have spent their lives and careers gaining. And even more importantly, all the patients have been a part of this journey as well. That we would only learn more when you are part of the process and all the studies that you will see we go through. Every person made such a big difference. So I'm grateful for that, and we've learned from them. So I'll start with some disclosures that are important to know. I do receive research funding and consultant support from some companies that will be mentioned in the studies that we talk about: Natera, AstraZeneca, and Vertex. And then I was a principal investigator for the RENACARE study, which is a genetic study that was sponsored by Natera. And I'm a site sub-investigator for the Amplitude study, which is sponsored by Vertex Pharmaceuticals, which we'll talk about in more detail later on. So what are the objectives of today's discussion? And first, we're just going to identify the disparity in rates of kidney disease in the U.S. across race and ethnic backgrounds, which I don't think anybody here will be surprised by. Then we'll outline the process that led to the identification of APOL1 variants as a significant contributor to kidney disease. We'll look at the functions of the APOL1 variants, both protective as well as potentially harmful, including potential mechanisms. Highlight the clinical implications of APOL1 variants in kidney disease. Then we'll look at the potential therapeutic pathways and look at the evidence that has come up already and what may be in the future. And then lastly, just consider the role of APOL1 directed therapy in the overall context of kidney disease in people of African descent. And of course, welcome your questions at the end. So everyone on this webinar has in some way touched by kidney disease. And so again, this is not news to anyone, but kidney disease is common in the United States. This is from the CDC that tracks kidney disease over time, and the most recent numbers that they have are from a few years ago. But it's still quite common that about 14% overall adults have chronic kidney disease in the US. But the real question is, how is that distributed amongst the population? Is that distributed equally? And of course, the answer is absolutely not. If you look at that same data, if you look at different self-defined race or ethnic backgrounds, non-Hispanic Black individuals are much more likely to have chronic kidney disease, almost 1.5 times the rates of non-Hispanic white individuals, and almost twice as many common as Hispanic individuals. And that kind of cuts along no matter which way you look at kidney disease. We look at kidney disease in a few different ways, as you guys likely know. We look at it in something called eGFR, or glomerular filtration rate, which gives you an idea of how much filtering function there is. We also look at something called albuminuria, which is protein leaking in the urine, which is a oftentimes first indicator of kidney disease, and even more importantly, one of the major contributors to kidney disease progression. So when we look at chronic kidney disease, we know it's common. When we look at albuminuria, it's common across the population. But I would ask the same question: is that how does that distributed amongst the population? And once again, if you look at the self-defined racial and ethnic backgrounds, non-Hispanic Black adults in the United States are much more likely to have albuminuria than their white or Hispanic counterparts. So whichever way you look at chronic kidney disease, there's a significant disparity across racial and ethnic backgrounds. So looking at that in more detail, the natural question is why? And so you go to the kidney disease surveillance system, this is the part of CDC that tracks this, and they have a comment on it. That African Americans, Hispanics, and American Indians are at higher risk of developing kidney failure, and the risk is because of higher rates of diabetes and high blood pressure in these communities. And I read that, and I know that that may tell part of the story, but clearly that can't tell the whole story, because you saw the disparities even amongst African Americans and Hispanics. And we know diabetes is common and high blood pressure is common. And so this can't be the whole answer. Now we know that kidney disease, as well as other chronic illnesses, are also impacted by structural racism and inequity in systems. But once again, does that explain everything? And thankfully, there are scientists and people that really wanted to dig deeper and say, okay, is there more to this that we can look for? Is there more to this that we can understand? So we go back to the 2000s and early 2010 era, when the human genome became much more readily accessible, much more easily able to analyze it and read it. And it led scientists to say, okay, well, we know there's variants in diseases. Are there differences in the genes that people have that may lead to certain illnesses or protect against certain illnesses? So genes provide us with a recipe of how we make proteins that allow for machinery of life. We know that everyone has many of the same gene variants, but we also know that there are many differences. That's what gives us our natural diversity: brown eyes, blue eyes, blonde hair, dark hair, etc. But when the standpoint of health and disease, there also may be variants that are particularly protective or potentially contribute to diseases. So again, looking at this, it's okay, well, how do we dig into this deeper? So they do studies called GWAS. So GWAS is genome-wide association studies. And the way they look at it is say, okay, let's take a group of people that have a condition, whether it's kidney disease or particular type of kidney disease that we'll talk about, FSGS, or any other condition. And let's take a group of people that do not have that condition. And then let's look at their DNA. Let's look at their whole genome. And then let's see if there are specific differences that are more sort of heavily weighted in one area or the other. Do the people with disease A have more likely to have gene Y? And that may lead to more understanding of A, why those people get the disease, but also a better understanding of how that may develop. So they've done this across many different conditions. And they first did it in terms of kidney disease and disparity in the African American population, looking at a specific type of kidney disease called FSGS. FSGS, many of you may be aware of, but it's more of a pattern of injury that causes scarring of the kidney. And the particular things about FSGS is that it does not respond well to most of the treatments we have. It's characterized by heavy loss of protein in the urine. And it's also characterized by a fairly rapid loss of kidney function. So we knew it's very important to look at this, but it's also fairly rare. And so while we learn from this, we know that there's probably more to this. But this is the population because this is sort of a high-risk population they looked at first. They said, okay, are there differences? And what they found is absolutely. So they took individuals, African Americans that had FSGS and African Americans that are healthier, and they compared those gene sequences. And what they saw is that in the APOL1 gene, specific variants were much more likely in the FSGS patients than healthy individuals. They call the variants G0, G1, and G2. And G1 and G2 are the ones that seem to be problematic. Individuals with FSGS were 3 times more likely to have a G1 variant of the APOL1 gene. And when they said, okay, well, does that really explain everything? Is it all because of the G1 variant? So then they controlled for that. And they saw, no, there's still another factor. There's the G2 variant. There's the G2 variant in that population. They're 1.5 more times more likely to have FSGS than healthy individuals. So, okay, well, does that explain all of it? So when they controlled for both, all the differences went away. So they thought, okay, well, maybe we're getting to something. Maybe we're seeing that this is really very much playing a role in the development of this specific type of kidney disease called FSGS. But that's a very specific type of kidney disease and a relatively rare one. So the question becomes, okay, well, is this more common? And I said, I can't explain all the disparity in kidney disease because it's something that's more common than that. So we looked at another study. There was a study called the AST study. It's the African American Study of Kidney Disease and Hypertension. And the original intention of the study was to look for differences in whether if you control blood pressure more aggressively or if you use specific medications to control blood pressure, such as ACE inhibitors, was that protective in African Americans with kidney disease? And the end result they saw was no, even if you were more aggressive with blood pressure control, even if you used medicines that we thought could be protective, you couldn't really protect people further. So again, suggesting there's more to this. So that's the same population. This is a more common type of kidney disease. These are people that label hypertensive chronic kidney disease, which probably doesn't really exist. And they looked at whether they had APOL1 variants. And what you can see in these 4 little 4 squares of the graph is that the top left, you see those individuals that had 2 copies of the APOL1 risk variants, meaning they had 2 genes from both chromosomes, a G1, G1, or G1, G2, or G2, G2. They had a much higher risk of developing kidney failure. And that graph, what it shows is that the lower the line goes, the more people are on dialysis or have died. So if you have 2 copies of the APOL1 variant, you're much more likely to live on dialysis or dying of kidney disease or heart disease. And then they said, okay, well, is it just APOL1, and how does that play into the other things we know about kidney disease, including losing protein in the urine? And so they looked again at if people had APOL1 risk variants, that they had protein in the urine. And what they saw is that if you didn't have any risk variants, they had no protein in the urine, you did the best. They had the best sort of outcome. If you had a high-risk APOL1 variant, and even if you didn't have protein in the urine, which we think generally is a low-risk condition, you did worse. If you had protein in the urine and you had APOL1 high-risk variant, you did even worse. And so we can see that APOL1 seemed to basically compound or go along with and make even worse proteinuria, which is already a contributing factor. The last thing they looked at is say, okay, well, that's understandable, but then can we control this? Can we target this with the things we're talking about? And just like in the broader population, they saw that no, even if you got their blood pressures lower, even if you got them on the right medicines for the kidney disease progression, it wasn't helpful. And so it didn't, if you had the APOL1 high-risk variant, it basically inhibited or restricted the effect that other protective things we would think would, the kind of effect they would have. So then they saw, people sort of realized that this is really much more common in terms of how it affects kidney disease. And so they looked at a very specific population of FSGS. They looked at a more broad population with hypertensive kidney disease or kidney disease with of the unknown origin. And then it looks at many other types of kidney disease, things like lupus-associated kidney disease, or diabetes-associated kidney disease, or HIV-associated kidney disease. And they saw that across the board, if you had high-risk APOL1 variants, it basically complicated every one of those conditions. So having lupus plus an APOL1 variant is much higher risk. Having HIV and having an APOL1 risk variant, much higher risk than without. And so what we can see more and more is this is an independent factor that's contributing to kidney disease progression. The natural question that comes up is then, well, why would we have this? Why, our bodies are supposed to develop, and evolution sort of selects over time the types of genes that help to survive. So why would we have gene variations that are clearly putting us at risk for certain diseases? And what we've now learned is that many of these things that contribute to disease states, at some point in our ancestral background, were probably protective against certain types of illnesses, particularly infections. And it turns out that the same variants that increase people's risk of kidney disease protects them from a particular type of parasite infection called trypanosoma, which causes sleeping sickness. Now, this is more prominent in sub-Saharan and Western Africa. That's where trypanosoma is more common, and so that's where these G1 variants, or sorry, G variants or APOL1 variants were selected for, so that people would be able to survive the parasitic infection, not, of course, understanding and only knowing, many generations later that these same protective things would increase people's risk for kidney disease. But we're learning that this is true for a lot of genetic conditions. Cystic fibrosis, for example, also a genetic condition, but the gene variation may be protective against other types of infections like typhoid or tuberculosis or even cholera. So it's a double-edged sword of having these gene variants that are protective in our ancestral background, but now may pose us a risk. And the processes are probably linked. And we're still trying to best understand exactly how this works. But what you have to do if you have an infection is basically kill the infected organism. So kill the parasite. So having a certain type of APOL1 variant allowed your immune system to be more aggressive and to eradicate those parasites. But that same activation that occurred to help people clear parasites, if that same air environment is in the kidney, what happens is the kidney cells get injured. And that is likely how this whole story really starts to unfold, where kidney cells are injured, which leads to protein loss in the urine, which leads to worsening kidney function, which leads to high blood pressure, et cetera, et cetera, et cetera. And that sort of goes along the whole pathway. So what can we conclude about the APOL1 variants that deal with kidney disease? So the gene variants are strongly associated with kidney disease, have a high risk for progression or progressed ESRD. The gene variants in APOL1 have an additive effect on conventional risk factors of CKD progression. So it's not just that they're associated with it, they're probably separate contributors. And they also reduce the protective effect of the conventional medications that we use to prevent CKD progression. So all the things that we like to do, control blood pressure, give people ACE inhibitors, angiotensin receptor blockers, things that you've probably all heard, don't have the same protective impact in people with high risk APOL1 variants. And so we have to say that this is a separate pathway of injury in kidney disease. And hopefully, and that's what we're hoping to be seeing, a potential target of therapy. How those therapies may work and how the APOL1 genes affect kidneys, injury exactly is still trying to be determined. This is a picture of the microscopic image of the kidney environment. So we have what we call the podocyte, which is the cell that kind of holds up the kidney filter. That is the fundamental cell that gets injured in a lot of kidney diseases that are progress rapidly. And so APOL1 is it's in the nucleus of those cells. What we know is that other stressors, something called interferon, which is a stimulator of immunity, kind of starts the process. And that can be sparked by many different things. Infections are a common thing. HIV, I mentioned, so-called parvovirus. We very much suspected COVID also triggered this. And once that's triggered, then the APOL1 activity is increased. Once APOL1 activity is increased, again, in these variants, there's probably other processes in this A, B, C, D, E, and F are all sort of different proposed pathways where cell injury occurs, or the cell becomes more fragile. And ultimately, if that cell becomes more fragile, that podocyte, that cell that's sort of holding up the backbone of the kidney filter, gets injured, and the backbone is injured. And the kidney filter starts to become leaky, and all the other things that happen that we see clinically. So I've talked a lot about the research and sort of a scientific level, but how important is this sort of day to day, and how relevant is this to clinicians such as myself? And so we ask a few questions. First, how common is it? Why should we look? Once we decide we're going to look, how do we do it? And of course, what can we do about it? So let's say first off, how common is this? You say, like, well, you're talking about rare diseases. Is this something that I'm really seeing? And the answer is almost definitely. This was the RenaCare study I mentioned. And this was looking, it was a multiple centers. So we were one site across the country that looked at a variety of kidney diseases, and the patients underwent genetic testing. And the idea was to collect a variety of background, different types of kidney disease, and see what gene variants of different genes that code for the kidney may be more present and perhaps be involved in the disease state. And what they found is that the APOL1 variants were the second most common positive genetic test result. And when you look at it in the context of the first and third most common were polycystic kidney disease gene variations. And while, again, those are very much important, we probably had a good suspicion that those individuals had polycystic kidney disease beforehand. As you can see on that, the B part of the image here, cystic nephropathy was a common reason why people were included in the study and then underwent genetic testing and then yielded a positive result. But when we look at the more, what we'd say, everyday types of kidney disease that probably are overlooked and people don't think of need a specific treatment, just kidney disease with protein levels. Nephropathy associated with hypertension, end-stage kidney disease, nephropathy associated with diabetes, or even early onset or severe familial hypertension. Even people that did not have really significant kidney damage, but just had very difficult to control hypertension, you can see APOL1 risk variants were commonly found in all of them. 45% coronary kidney disease, 31% nephropathy associated with hypertension, a third in the people that had end-stage kidney disease, almost a quarter of people that had nephropathy associated with diabetes. And again, in those individuals that just had hypertension, more than half had APOL1 risk variant. So how common is this? Much more common than we think. So why should we look then? It may seem sort of obvious, but I think it has to be said because we aren't looking enough right now. If you look at when people end up on dialysis, nephrologists are asked to fill out a form. That form says, okay, what was the cause of this person's kidney disease? And this data is a little bit older, but it hasn't changed that much. But in this data, there was a study published in 2012, over a third of cases of end-stage renal disease in African Americans were classified as hypertensive nephrocirrhosis or hypertension-associated kidney disease. Is that really true? Well, think about this. If you excluded things that we know are clearly genetic, like polycystic kidney disease, hereditary nephritis, more than 30% of African Americans initiating renal replacement therapy, dialysis or transplant, have a close relative on dialysis, and many more have relatives with silent kidney disease, have protein in the urine, or reduced GFR, or just very difficult to control hypertension. Does that really make sense that this is all due to hypertension? So, as a clinician, as a scientist, as like to think a thoughtful person, identifying individuals with APOL1 variants is important for accurate diagnosis. It's lazy to say this is hypertension when we can look for other ways or other explanations. More than that, though, finding this out, I think, shares with patients a better picture of their condition, even if we aren't quite at the state where we can do something about it. But I also will say, I think it's important because it reduces stigma. I've been a clinician for almost 20 years, and unfortunately, I've seen many times where young African American individuals with kidney disease and very difficult to hypertension are labeled as non-compliant, or they don't take the medications, or they can't be on their diet. And clearly, that's not the case. The case is that there's a genetic underpinning, and probably that's not all, many of these individuals that has led to their condition that the treatments that we have available right now are simply not enough. And so it is good medicine, in my mind, to find these variants, identify them, share it with patients that they have these, and then contribute to the process of looking for solutions. So how do we do it? Thankfully, this is readily available. I think we're going to put a link in the chat. The NPFI website that shows you how you can connect with APOL1 testing. This is from the American Kidney Fund, which is another organization that works with patients with kidney disease, that can sort of walk you through the process if you're interested in looking for screening for an APOL1 variant. There's also a direct commercially available test. So, any nephrologist, self-included, or anyone that we're seeing, any physician can order a test through these companies here, Para and Vitae, Arcana Laboratories. They will do the APOL1 variants and give you results. It takes a few weeks, maybe a month or two at most, but we'll have those results. Naturally, there's a lot of mixed feelings about genetic testing and what that means and what people want to know. But from a clinician standpoint, critically important at least, talk to people that are at risk about it, offer them the testing, and then have an open, healthy discussion about what that may be. That all being said, what do we do about it now? If we find an APOL1 virus variant, we know all the bad things I've already said about it can contribute to. So what's important? Are the basics still important? Absolutely. We still want to control their blood pressure. We still want to target weight control. We still want to target blood sugar control. We know that certain types of diets are healthier, but really, can we do more? And that's really the question that we are looking to answer now, and we're at the cusp of, which gives me a lot of excitement and hope for the future. So let's see here kind of where we are right now. And I see this is a lot of letters and a lot of numbers that may not necessarily speak to individuals, but that's because these are medications that aren't available yet. Before a drug becomes available, oftentimes it's just a number and a letter, a series of numbers and letters, or letters and numbers from a company. And the idea is that there are different pathways APOL1 may be leading to kidney injury. And so targeting different pathways is probably the best approach. Which is the best pathway, we still need to know. But as we explore, hopefully we can get to the point where we know not only which pathway is best, but which pathway is best for that person. So different strategies. One is blocking ion influx, so charged molecules, calcium, chloride, things like that. They go into the cell and may lead to injury. There's something called antisense oligonucleotides, which is a very exciting form of therapy where it actually interferes with the transcription of genes, so the proteins that our genes make stops them from doing that. And so whatever pathway that leads to injury is halted at the source, or blocking one of the pathways of inflammation. A lot of these injuries occur because of inflammation, and that's where this drug called baricitinib may play. Where we are the furthest is with the first drug I mentioned called inaxaplin. And I just want to go through this, the early studies, so you can see kind of where we are. And this is called a phase 2A study, so very small. It's looking to see, okay, we've seen its phase 1 studies or studies that looked at in healthy people to see the medication is safe. They can see how it's processed by the human body. Phase 2 studies are when they look at actual, is it going to be effective? But they're small. And so they took a small study. It was, you can see, sponsored by Vertex Pharmaceuticals. It was conducted in the US, UK, and France. And their criteria were the following. The people had APOL1 risk variants, actually had the biopsy proven that FSGS diagnosis. They had protein in the urine, they were treated with standard care, and they were given this new drug called inaxaplin. What do they see? They saw 12 of the 13 people had a reduction in urine protein. I mean, that's important because we think urine protein is sort of, again, the first signal that the kidneys are injured, and reducing urine protein is a signal that you're protecting the kidney and reducing stress in the kidney. So all except one patient had a reduction in urine protein, and 9 out of 13 had what we call clinically meaningful reduction in urine protein, which is over 30%, because we think that number translates into long-term kidney protection. But that was just at week 13. That was only basically 3 months of treatment. Overall, the group as a whole, they reduced their amount of protein by almost half by week 13. And of course, every drug has side effects, and there were mild effects that they noted, headache, back pain, the ones that were most commonly reported, but they weren't as severe to cause treatment discontinuation. People were able to stay on the treatments despite those symptoms. They looked further and said, okay, what happens if people come off the treatment? And that's the top graph there. You see after the people came off, protein urine did pop back up, not back to where it started, but it did pop back up, which tells you a few things. One, the drug's probably working. But two, there's some effect that lasts longer. In terms of kidney function, we saw kidney function stayed stable during that time. So at least we know we preserve things, whether over time, against a short period of time we looked at, which time that would be the kidneys improving, still too early to tell, but at least we can say that those kidneys stayed healthy during that period of time. So the initial evidence is that targeted inhibition, targeted blocking of the APOL1 function reduced protein in the urine, which we know is a marker of kidney filter injury that has been associated with progressive kidney disease. So very exciting, published in our sort of the biggest sort of scientific journal we have, the New England Journal of Medicine, and has led to excitement on my part and many others in this field. But it's always a but. Initial results are promising, but we need more. And so there's a phase 2/3, which is it will be different styles of doing the study, but overall it's a larger study looking at the active drug with the control group. So we always like to say, okay, is a drug really working? And the only way we can really say that, and the only way the FDA will approve a drug, is if the drug is compared to a control or a placebo. And what are the criteria looking at? They're actually expanding it. So it's people with adults age 18 to 65 that have 2 high-risk APOL1 alleles, that have some degree of protein in the urine, that have some degree of impaired kidney function, but not on dialysis or not near dialysis. They have to be getting standard treatment already, because we know these things need to be in the background. And they should have another cause of their kidney disease. We want to really hone in on those that probably have APOL1 kidney disease. So where is this trial being conducted? Over 250 sites across the world. This is all the sites that you can see by number where they are across the world. And thankfully, we have 2 sites right here, Chicago, and we are honored and grateful to be part of that. And so we have one of those study sites, and myself and my colleagues are the investigators. I will say, aside about clinical trial participation, because I do clinical trials, meaning I'm an investigator, but it's important to talk about, honestly, about clinical trial participation. Participation in clinical trials should never be expected. And when people talk about it, should never affect your decision or how your care is delivered. And it's important to know that in phase 2 and 3 studies, those studies that are going to lead to FDA approval, is almost always a control arm. So if you're in the study, you're guaranteed to receive the current standard of care. You should be getting at least the best baseline treatment we have, but you may not receive anything additional. You will maybe get some other benefits. You get additional clinical oversight, maybe an extra set of eyes, extra set of hands, extra set of expertise looking at your care. There's some payment that comes through with participation, but really, we must be clear that this is largely a selfless act, because the advances of tomorrow built on this selflessness and willingness of clinical trial participants to be part of the process. But the part of the process, safety and autonomy are the most important factors. So we welcome, we're grateful for people that participate in clinical trials, but those all things have to be kept in mind. This is not the only therapeutic option or only target being looked at. Like I said, other targets and therapies in the pipeline. We are happy to see that both big and small pharmaceutical industries have dedicated to this. Lilly, AstraZeneca, Vertex, we talked about, and smaller companies, Maze and Ionis, are all dedicated to this space, and the space has been largely overlooked. But of course, that's going to take a coordinated and complete effort of the nephrology and the science community, as well as the community of the individuals with kidney disease of African American descent or African descent to get through this. So I'll end with a few last thoughts. As you can see, I'm very excited about this. But I also know, realistic, will targeting APOL1 solve kidney disease in people of African descent? And of course, it's an important tool. We hope to have these, but we know that kidney disease, like other chronic diseases, is linked to structural and institutional racism that exists in the US and beyond. This leads to this cosmic weathering, where eroded health is caused by repeated harmful experiences that start at a young age and persist. So, this has been sort of a global approach. The whole approach is said most, I think, well by two people. Dr. Deidre Cruz in the top, she's a professor of medicine at Johns Hopkins, and also the president of the American Society of Nephrology, and Dr. Tanjala Purnell, who's a professor of epidemiology and faculty at Johns Hopkins. And they wrote this in 2020. Investing in the health and well-being of Black people means addressing the root causes of weathering and by default, systemic racism. This has to happen both at a societal level and an individual level. Each of us has to play a role in this. Societal level, every one of us has a role to play in dismantling the structures that led to what we see today in these inequities. So just to conclude, kidney disease disproportionately affects individuals of African descent, and the difference is not explained by conventional risk factors. Genetic studies led to the discovery of the APOL1 gene, which has specific variants to protect against sleeping sickness, but increase the risk of kidney disease across the spectrum. Conventional treatments targeting blood pressure control, diabetes control, they're necessary, but not sufficient to improve the outcomes of APOL1-mediated kidney disease. Multiple targets of APOL1 pathway treatment are in development, with panaxaplin, small molecule ion channel inhibitor, demonstrating early success in reducing proteinuria, which has led to effort to execute a larger study that could lead to FDA approval. Clinical trials investigating panaxaplin and other therapies are ongoing and upcoming, with all across the U.S. And of course, the complete coordinated effort of the nephrology community with the community of those of African descent to advance scientific discovery and dismantle structural racism and inequity were the only way to successfully reduce the burden of kidney disease that currently exists. And with that, I will stop and welcome your questions, and thank you again for your attention.
Thank you so much, Dr. Udani. My goodness. Wow, wow, wow. You really broke that down for us in a way that was understandable. And I personally appreciate it. I know our audience does. We do have time for questions and answers. There are right now 2 questions in the chat. The first one is for Joanne. And there's still time to put other questions in the chat if anybody has any. So Joanne, Talia Bradford wants to know, did either of your parents have kidney disease?
My father had polycystic kidney disease, and myself and my daughter inherited it from him.
Thank you. And then Talia Bradford wants to know, does COVID-19 associated nephropathy affect other kidney diseases as it does with FSGS? Dr. Udani?
Yeah, so the short answer is it most definitely does. We think that COVID-19 stimulates this interferon pathway and stimulates APOL1 activity. So even beyond FSGS, people with hypertension at baseline may develop kidney disease as a result, or have diabetic kidney disease at baseline may get significantly worse as a result of this pathway. So we're still working it all out, but almost definitely it is playing a big role, and we saw that a lot definitely in the earliest parts of the pandemic.
Okay, thank you. Let's see, we have an attendee who has their hand raised. Rachel, can you see that and unmute them so they can ask their question? Oh, I see a question in the chat too. In the meanwhile, a question about how to participate in a clinical trial in Illinois.
Yeah, so the first thing is, I'll happily give my contact information to our research site so that people that are interested, can call and contact us and start what we call the screening process. And the screening process is basically saying, okay, where does your kidney function at? Do you have that fit those criteria that we have outlined? And then they walk you through what the process entails. And every point in the pathway, or every step in the process, you can say thank you, but no thank you. But the point is that to give you all the information to see that that this would not, being in this study would not put you in increased risk for anything else, and then seeing if this is the right thing for you. So I can share that. I'll share that with you, Monica, and maybe I can then put it back in the and distribute it.
Okay, thank you. Here's another question. How can healthcare companies work toward this targeted therapy, and how can we make it a priority for those companies?
I think that the voice of people makes the biggest difference. And discovery takes us so far, but when there are people advocating for it, when there's a population that we know is active and saying we need better, that's how even with rare diseases we've been able to make progress. So whether it's APOL1 and the African American community or any other disease state, coming together, coordinated efforts, things like this, working with other partners, National Kidney Foundation of Illinois, other organizations to say, okay, we're going to do this is important. This is an unmet need. How can we push this through? And I think the first step is if these trials succeed, meaning that the trials can successfully get people in, most of them first, and then show the drug is impactful, then that helps reinforce other companies say, hey, this is a worthwhile, and I think it's worthwhile, meaning for them, it's money, it's a dollar scheme, and unfortunately for a lot of them. And so, but it reinforces their sort of effort to say, okay, yes, we need to be involved in this. There's a question about the cost, and it's a great question that we just don't know. It's still in study, and so until that medication gets approved, we won't know. If you're part of the study, all the study-related costs, including the medication, are paid for by the study. People don't pay for that out of their own pocket or insurance.
Okay, thank you. Rena wanted to ask a question. You've been unmuted, Rena, if you want to ask a question. Okay, maybe not. All right, there's another couple of questions in the chat. When it comes to COVID-associated nephropathy, why do some patients recover from acute tubular necrosis and others don't? And what can help recovery?
That's a good question. And unfortunately, we don't really know the answers to that right now. We think it's likely related to APOL1 pathway. Perhaps people that get medicines that clot inflammation, like steroids, may do better in some cases, but has not been proven to be that way consistently. So I wish I could tell you that we knew exactly why there's such wide variation, but we just don't know yet.
Okay, thank you. Next question is, what advice would you give to potential kidney donors who carry the high-risk APOL1 alleles? Would you advise them not to donate? What percentage of those with high-risk combo actually progress to have renal insufficiency?
So this is a very, again, important question that is still being discussed by transplant centers. And I will say the caveat is I'm not a transplant nephrologist, and so I don't make the transplant policy. Transplant policies are developed by each individual region. And so I don't think that by itself, having high-risk APOL1 variants should, and this is my opinion, so this is not universal policy, should exclude someone from being a donor. But it has to be, carefully considered, and their overall health also needs to be considered. And to say, we know there is a risk, but it has to be really based on all your other risk factors, because we say the APOL1 contributes to all the other factors underlying. So you have normal kidney function, normal blood pressure, don't have any other illnesses that may, including PKD, then the likelihood is that, much more likely is that their kidney function will be preserved through their lifespan. But we need to do that at a very individual level, and it has to be a discussion between the donor, the recipient, the transplant center to say, okay, these are the risks that we can tell you specifically. This is how we would try to reduce that risk. And then the decision is a shared one. And we hope that even if that risk is higher, if there are therapies that become available, then that can lower that risk as well. So I think that even when we talk about this for people with, disease that begins or existing disease, I think that potential donors will be another group that would benefit from this, because that's such a high need in the kidney community.
Thank you, Dr. Udani. Another question is, what is the anticipated cost for this type of treatment?
Yeah, it's too early to tell. I expect, just how new therapies are, I expect it to be expensive. That doesn't mean it's the case. And how the company prices it will be determined over the next few years if the drug actually gets approved. But those that are involved in the study, they're not, the cost of the medication as well as all the other parts of the study are included as part of the study. So you're not paying for that yourself. But how much it will cost, I wish I could tell you, but I know it'll be significant, but what that means, I don't know.
Okay, thank you. Another question, Joanne, this one is for you. It's for you and Dr. Udani. What advice would you give to kidney patients like yourself, Joanne, and families in the African American community who feel they may be at increased risk for kidney disease? Like, what questions can they ask or steps they can take with their doctors to find out more?
I would say learn as much as you can about kidney disease and ask multiple questions, and don't take no for an answer. The way my kidney disease was presented to me, it was as if I had a cold and nothing to worry about. And I had normal functioning, so I didn't think anything of it, but you have to be on top of it. Do research, study, and through your research, you'll learn the appropriate questions to ask. But if they tell you you're spilling proteins in your kidneys and your blood pressure is elevated and things like that, be proactive in getting more information on how you can slow that progress down and become involved in studies as well, because the medication is free and it helps develop treatments in the future, and it helps you in the process.
Okay, thank you. Dr. Udani, did you want to add anything to that?
Really exactly that. I think Joanne's nailed it. Asking one question, saying, what in 2024, what are all the ways that we know that we can protect my kidney disease? And what is the most specific type of kidney disease I have? I think that's important, because you have PKD, and it's not that people just have one thing. They get PKD plus APOL1, they get PKD plus something else, APOL1 plus something else. So it's all, so what information can I have about to get as specific as I'm able to about the nature of my kidney disease, and what are all the available treatments? So I don't have to take all of them. Well, that way that the person you're talking to is keeping up to date with all the therapies that are available. And then you decide on what works best for you together.
Okay, thank you. Okay, we're moving to the 4 o'clock hour. Actually, it's 4 o'clock right now. I'm going to ask this one last question because this person has been waiting patiently. What food should you avoid to help control the disease? Dr. Udani?
Yeah, so healthy eating, does play a role. Like I said, it's not necessarily the only thing, but the best things to sort of keep in mind are a diet that's rich in fruits and vegetables, a diet that's low in salt and sugar, and a diet that's low in processed foods or prepackaged processed foods. The fresher you can eat, the better. The more fruits and vegetables you eat, the better. Doesn't mean you have to be vegetarian, but we know plant-based diets are healthy in a lot of different ways. But if you're going to eat the non-plant, it's important how it's prepared, what's added to it, trying to avoid salt, sugar, and the processed things that add phosphates and other minerals that are makes the kidney have to work hard.
Okay, thank you. And this is the last one. There's one more question just showed up, and I think we need this answer. Since APOL1 associated FSGS is gene related, does this mean that transplanted patients still have the disease? Is there a higher probability of transplant failure or rejection?
Yeah, so it's a good question, and there does seem to be you still have so unlike certain genetic kidney diseases, if you get transplanted, you still have the APOL1 gene, and the APOL1 gene exists, not only in the kidney, and so there has been a higher association with graft failure, not necessarily rejection, but graft failure, and exactly the pathway of that is not clear. It's not always recurrent FSGS in the way that there's the recurrent FSGS people leave lots of protein right away, but it is something that increases the risk. So again, it should not preclude people from getting a transplant, but it is important to know that all the other things that we can do to protect the kidney, native or transplanted, become super important, and finding other ways to target that pathway remain very important.
All right. Well, thank you very much. Wow, this was a super engaged audience. Great questions, great information shared. And you said two words, Dr. Udani. You said you were excited and oh shoot, now I forgot the other word, but about the future of what is to come with kidney health.
I'm optimistic. I'm excited and optimistic. I think
Yes.
we're cautiously optimistic, but I'm hoping that we can be better at doing what we're doing right now. We need to be, because what we're doing right now is not good.
Yes, thank you so much. I'm excited too. So glad to hear this information, glad to know what's on the horizon, and that it's being used in a way that will help African Americans avoid dialysis and avoid needing transplants and things like that. So that is just wonderful news to me. That information will be used for our good. So I just want to say thank you. Thank you to our panelists. Thank you to everyone who attended and who hung out with us. We're a little past 4, but obviously you all agree this was great information that we all needed. I want to thank our sponsor, UI Health, for sponsoring this webinar. I want to call your attention to our podcast. So if you want more of Dr. Udani, we happen to have a podcast with him called Hand Me Down Genes. You can hear directly from him on all podcast platforms, Spotify, YouTube, iHeartRadio, on your iPhone, all of that. So check out the podcast if you get a chance. And then we have upcoming programs. They are listed here. And our walk is coming up on July 9th. So everybody loves a good walk, and ours is one of the best. So I encourage you to look for the information. You can set up your teams now and get started. I know I'm getting ready to start my my team, or join my team. And we just want you to follow us on social media. We're on Facebook, Instagram, YouTube, you name it, we're there. Twitter, LinkedIn, look for us there. And we are looking forward to seeing you next time. Put the list back up for events. Rachel, can you put the events list back up? So we have World Kidney Day coming up next, March 12th at the Courtyard Marriott in Chicago, in the medical district. We're also on actual World Kidney Day, March 14th. We'll be down in East St. Louis having a kidney screening. We got a couple of sessions to take charge. Kidney Connections will be coming up in March, June, and August. Our ICRN program is April 18th. So we got a lot of programs coming up. All this information is available on our website. So you can go to nkfi.org and look up events or look up programs, and you'll find all that information for everything that we have coming up. Jackie has her hand raised. Can we unmute Jackie so she can talk? Jackie, you want to say?
Just real briefly, thanking everyone. And just a friendly reminder, the walk is June the 9th at Diversity Harbor. So it's on the list. And, we are excited to see everyone come. And thanks to our panelists and to our moderators, phenomenal information. And wishing everyone an awesome afternoon.
Thank you. Thank you everyone for attending. Have a good
Thank you.
day.